The goal of this video is to help you get ready for the Chapter 1 exam. We'll go over the main ideas from the chapter, and I'll try to point out some of the details that occasionally give students trouble. One of the major themes of the chapter is solving equations. We learned how to solve lots of different types of equations. So let's start with that. First of all, you should be able to recognize what type of equation you have. So do you remember what a linear equation looks like? It just has x to the first power, or just x in the equation. A quadratic equation, on the other hand, has x squared in the equation. Do you remember the rational equation? It has the variable x in the denominator of a fraction. The radical equation has a radical in it, has the variable underneath the radical. Usually it's a square root, although it could be a cube root or a fourth root or something like this. We also looked at fractional exponents. That's just what it sounds like. That's a fraction applied to the variable. So for example, you could have x to the 2/3 power or x to the 3/2 power or something like that. We also talked about quadratic in form equations. Those are a little more complicated. I think the example that we did in the video had x to the 4th and x squared in it. And then the last type of equation was an absolute value equation. And we recognize the absolute value symbol in the equation. Okay, so let's back up and let's talk about each of these different types. For the linear equation, probably the main takeaway was to remember the distributive property and also to remember how to clear the fractions in an equation. We also learned in section 1.1 that an equation could have no solution or it could have an infinite number of solutions. Of course, most linear equations have exactly one solution. Most quadratic equations have exactly two solutions. Quadratic equations were more complicated, and we found 4 different ways to solve a quadratic equation. The first way was by factoring. And remember, we learned a special type of factoring called factor by grouping. Be sure you can do that on the exam. We also learned a quadratic formula. I won't repeat the quadratic formula here, but it's in a video for section 1.4 and it's in your homework and you should definitely know it. So instead of trying to give you all of the details for the entire chapter, I'll try to remind you of things like a quadratic formula and ask you to go back and find it in your notes and be sure to know it for the exam. Okay, we also learned about the square root property. And then the hardest method for most students is completing the square. And I think the reason it's the most difficult is just because it has the most steps. Maybe you remember there was about a 4 or 5 step process that we followed to complete the square. And ultimately, we wound up using the square root property near the end of the completing the square method. So make sure you go back and look at completing the square again. Remember the homework in section 1.4 and also the problems on the exam will tell you which method you should use to solve each problem. So you'll need to know all 4 methods. For a rational equation, remember that just means the variable is in the denominator, and so the key step was to clear the fractions. And to do that, all we had to do was multiply the entire equation, both sides of the equation, by the least common denominator. We also talked about identifying the domain of the equation and making sure at the end of the problem that we didn't wind up with an extraneous solution. If we got a solution that's not in the domain, then we have to throw it out. And there's a similar idea with the radical equations as well, except we can't just check the domain at the beginning of the problem. So instead, the key idea for a radical equation is that you must check your answers by plugging them back into the original equation to see if they make a true statement. The other big idea for a radical equation is just how do you get rid of the radical? And most students remember that they need to square both sides to get rid of a square root. And of course, you have to have the square root alone on one side of the equation before you square both sides. Another important takeaway from the rational and the radical equations is once you, when you have a rational equation and you clear the fractions, then you're either going to have a linear or a quadratic equation left over. Same thing for a radical equation. Once you square both sides and get rid of the square root, then you either have a linear or a quadratic equation left over. And so then you can apply the techniques that we already learned in the earlier sections. For fractional exponents, probably the biggest takeaway was to remember properties of exponents. And so there are some details there that you'll want to go over again before the exam. And then quadratic in form. For an equation that was quadratic in form, we needed to make a substitution. And the substitutions that we made, for example, was something like let u equal x squared, and then u squared equals x to the fourth. So for example, if the equation had x to the fourth and x squared in it, then that's a good clue that it's quadratic in form. And if we made this substitution right here, if we replaced the x to the fourth with a u squared, replace the x squared with u, then we wind up with something that's quadratic. So I won't write out the example right here, but that example is in the videos for section 1.6. The last type of equation was an absolute value equation, and there were two special cases. We said if we have the absolute value of x is equal to a, then x equals a, or x equals negative a. Too many times I see a student who remembers the first part, that's great, but forgets the second part. And so essentially all they've done is just dropped off the absolute value without any consequence, right? And so maybe a big idea in this chapter is that everything you do has a consequence, or you have to balance it out. So if you want to drop the absolute value, for example, that's great, but there's this other case that you have to consider, x equals negative a. There was another absolute value equation where there was absolute value on both sides, and we could drop off both absolute values just the same way we dropped off the one absolute value. So we get x equals a or x equals negative a. And we said in this first case that a must be a positive number, And in the second case, a does not have to be positive, and it does not have to be a number. It could have a variable as well. And so those were two big differences. Okay, so those are the highlights for solving equations. Once we solved equations, then we wanted to solve inequalities as well. And notice in this list of inequalities, you see a lot of the same vocabulary as we saw for the equations. So we learned to solve a linear equation, and we learned a linear inequality, for example. And so what was the big takeaway from a linear inequality? It was probably just that we have to switch the direction of the inequality symbol whenever we multiply or divide the inequality by a negative number. So don't forget that one. When we solved a three-part inequality, remember we did the same thing to all three parts of the inequality. So just a real quick example, if I have 3 is less than x plus 10, which is less than 8, then you would say, let's subtract 10 from all three sides of the inequality, and then we get a compound inequality that we can write in interval notation. When we solve quadratic inequalities and rational inequalities, those are probably the two most difficult problems in the entire chapter, based on what I've seen from students over the last 5 or 10 years. So again, there's a 5-step process, approximately 5 steps that you have to follow, and you really have to know what those steps are and go through them carefully. You can't just make up a process. You can't just treat it like you treat an equation, for instance. So the key idea was for the quadratic inequality was to solve the corresponding equation, and then to use the solutions from the equation to create test intervals. So those are candidates for solutions, and then we just have to test each of those intervals with a test value and see if it makes a true statement or not. And so there's a similar process for the rational inequalities as well. So be sure that you go back through process for each of these types of problems. I say it's a long process. 4 or 5 steps feels long to us today, maybe, but later in the course we'll see problems that are still more complicated than that. Okay, the last type of inequality was an absolute value inequality. There were 2 cases. We said if the absolute value of x is less than a, then we can drop off the absolute value and create a 3-part inequality. And there it is. And if the absolute value of x is greater than a, then we have 2 disjoint intervals. We have the interval where x is less than negative a, and the interval where x is greater than a. The other thing that I want to mention with the inequalities was interval notation. And so be sure that you're comfortable with interval notation and when to use parentheses and brackets, and maybe just a real short example. If I, for instance, had the inequality x is greater or equal to 3, then do you know how to write that in interval notation? That interval starts at 3 and it goes up to infinity. And we always put parentheses on infinity. And in this case, we'll put a bracket on the 3 because of the equal underneath the greater than in our inequality. So that's a real short review of interval notation. But remember, you were writing all of your solutions for the homework in interval notation. So you should expect to do that again on the exam. Okay, a couple more topics. We talked about complex numbers in section 1.3. Remember, a complex number looks like a plus bi, where I is equal to the square root of -1, and so I squared is equal to -1. We talked about how to add, subtract, multiply, and divide complex numbers, and the division was the most complicated of the four, and you should definitely be ready to divide complex numbers on the exam. Why did we study complex numbers? The reason is because in the very next section, in section 1.4, we solved quadratic equations. And those are the ones that get us oftentimes, not always, but oftentimes, to non-real complex solutions. So when you're solving a quadratic equation, be ready to wind up with when you're solving a quadratic equation, be ready to wind up with a non-real complex number for your solution. Okay, just a couple more things. Word problems that give quadratic equations, that was in section 1.5. There were some formulas that you needed to know in order to do those problems. For example, the area of a rectangle, or the perimeter of a rectangle, or the Pythagorean theorem. Go back through the homework for 1.5, make a list of the formulas you needed to do the homework, and then make sure you have memorized all of those formulas before the exam. You'll need at least one of those formulas again when you're doing the exam. The exam questions from 1.5 will look similar to the homework questions from 1.5. And I guess in general, that's true as well. Generally speaking, exam problems should look similar to homework problems and also problems from your notes. Okay, here at the end, I would just mention that we skipped section 1.2, and so you shouldn't be concerned with that material. Okay, go back through the homework and the notes and the review problems for the exam, and good luck.